Ghana Teacher Licensure Exams 2025. So this is Numeracy, and then we have some diagnostic tests on Algebra. So in this particular test, there are 10 multiple choice questions. And then I hope that after we are done solving all these 10 questions, it will prepare us adequately for the upcoming Gtle in the middle of October 2025. So there's our first question. So I read, there are X men, Y women, and then Z children in the church. You are to write an expression for the total number of people in the church. So with question 1, you could see that there are 3 categories of people in the church. So the first category, we have men. The second category, we have women. And the third category, we have children. Now, the number of men in the church was given as X. We have Y women and then Z children. Our goal here is to write an expression for the total number of people in the church. So let's say in the church we have 5 men, we have 10 women, and then we have, let's say, 6 children. Then can we find the total number of people in the church? Yeah, so the total number of people in the church will be the sum of the 3 different categories of people in the church. So we have 5 men plus 10 women plus 6 children. So 5 plus 10 plus 6. We have 21 people. But at this time, we have X men, Y women, and then Z children. So the total number of people will be the sum of the 3 different categories of people in the church. So the right answer to question 1 is C. Now, question 2. Question 2 reads, Tavia is X years old now. Tavia is X years old now. So how old was he 7 years ago? So let's say we have Kofi, whose present age is, let's say, 20 years. His present age is 20 years. So how old was Kofi 7 years ago? So 7 years ago, Kofi was 13 years. Kofi was 13 years. How did we get the 13? We subtracted 7 years from his present age. You see that 20 minus 7, that is 13. So with this same idea, can we also tell Tavia's age 7 years ago? Yes, we should be able to tell Tavia's age 7 years ago. Now we know that his present age is X years old. So 7 years ago, we have to subtract 7 from his present age. So 7 years ago, Tavia was x minus 7 years old. The right answer to question 2 is option D. Question 3. The sum of 3 consecutive natural numbers is 18. We have to find the least of the numbers. So what do you mean by 3 consecutive natural numbers? 3 consecutive natural numbers. So first of all, you know that natural numbers here are also known as counting numbers. Natural numbers are also known as counting numbers, and I hope you can list them. So the first natural number here is 1, followed by 2, we have 3, we have 4, 5, 6, 7, 8, up to infinity. So these are natural numbers. But what do you mean by 3 consecutive natural numbers? So when we talk about 3 consecutive natural numbers, we are looking at natural numbers that follows in a definite order. So now, if I ask you to list 3 consecutive natural numbers starting from 1, then our answer will be 1, 2, 3. So from 1, the next one is 2, and then the third one is 3. Now let's also list 3 consecutive natural numbers starting from 4. So 3 consecutive natural numbers starting from 4, that will be 4, 5, and then 6. So now we all understand what it means to list 3 consecutive natural numbers. But then we are not looking at the numbers as it has been listed, but we are looking at the algebra of the numbers. How do we represent 3 consecutive natural numbers algebraically? So to get this, we need to find out how the natural numbers occur. So now let's look at this particular pattern. Now we can see that for the natural numbers, the first natural number here is what? 1. So from 1, the next natural number is 2. From 2, we have 3. From 3, we have 4. From 4, we have 5. From 5, we have 6. In that order. Is there any pattern? Does the sequence have a definite pattern? The answer is yes. We see that from the first natural number to get to the next natural number, there is an addition of 1. From 2 to get to 3, there is an addition of 1. From 3 to 4, addition of 1. From 4 to 5, addition of 1. From 5 to 6, addition of 1, in that order. So now this time, let's say I have my first natural number as x. So how do I write my second natural number in terms of x? So if x is my first natural number and I want the next natural number after x, I just have to add 1 to x, and that will give me x plus 1. So now there is my second natural number. So to get my third natural number, what do? I still have to add 1 to my second natural number. So initially I was having x plus 1, and then now I am adding 1. So I have x plus 2 as my third consecutive natural number. So this is the algebraic representation of 3 consecutive natural numbers. So if the first one is x, then the second consecutive natural number must be x plus 1. The third one must be x plus 2. In other questions, you can be asked that the sum of 5 consecutive natural numbers. So can you write the algebraic representation of 5 consecutive natural numbers? So if the first natural number is x, and the second one will be x plus 1. The third one will be x plus 2. The fourth one will be x plus 3. And then the last one will be x plus 4. But with respect to this particular question, we were given the sum of 3 consecutive natural numbers. So you can say that let the numbers be. So if the first number is x, and the second one will be x plus 1, and the third one will be x plus 2. Remember, their sum. In algebra, sum means addition. So when we add these 3 consecutive natural numbers, that should give us a sum of 18. So we have x plus x plus x. That is 3x. Then 1 plus 2, we have 3. And this must be equal to 18. You can group like terms. So we have 3x is equal to 18, then minus 3. So 3x, 18 minus 3, that is 15. Because we are looking for x, we divide both sides by 3. So the 3 will cancel out, leaving x as 5, because 15 divided by 3, that is 5. So now can we list the actual numbers, the 3 consecutive natural numbers? Now that we know that the first number is 5, yes, we should be able to list them. 3 consecutive natural numbers starting from 5. So if the first number here is 5, then obviously 5 plus 1, we have 6, and then 5 plus 2, we have 7. So these are the 3 consecutive natural numbers whose sum is 18. Let's verify and see whether when we add up these 3 natural numbers, we will get 18. The first one here is 5 plus 6 plus 7, and that is 18. So our answer is correct. But then we have to find the least of the numbers. Least here means the smallest of the numbers. It is clear that 5 is the least number. So the right answer is option A. Now, question number 4. Question number 4. The student score in a test must be between 80% and 90%. If X represents the student score, then we have to write an inequality to represent the above information. So we have 2 given scores. We have 80% and then 90%. Remember, X represents the student score. X represents the student score. And again, the student score must be between 80 and 90, meaning that we are not supposed to include 80 and 90. So we are looking at the range of numbers that is found between 80 and then 90. So we have less than and then less than. So with this, the right answer to question 4 is also option A. Question 5. So a budget B for a project must be at least 10,000 Ghana cedis, but not more than 20,000 Ghana cedis. You have to write an inequality to represent the budgets. So let's do a quick revision here. So let's say we have these students with the following ages in a particular class. So we have 10, 11, 12, 13, 14, and 15 years. So these are the various categories of ages of students in a particular class. And let's say we want to select some age group for a particular program. Now the rule says that the selected students, their ages must be, let's say, at least 11 years old. So their ages here must be at least. So at least they must be 11 years old, but not more than 14 years. Not more than 14 years. So now can we list the students that could be selected? So if the student age must be at least 11 years, then it means that we can select students whose age is 11 years. So at least, meaning that the smallest age must be 11 years. We can select students with the ages of 12. We can select 13. What of 14? Person said their ages must not be not more than 14. So we can still select 14. It shouldn't be more than 14. So if it shouldn't be more than 14, then it means that it can be 14. Just that it shouldn't be more than 14. So these are the categories of students that can be selected for the program. So can we represent this using inequality? You could see that the reference ages here was 11 and then 14. So let's say we are representing their age with the variable y. So meaning that their age must be in the middle. Remember, we selected 11 years. We also selected 14 years. So let's apply the same concept to solve question 5. So this was the reference money for the budget. We have 10,000 Ghana cedis. We have 20,000 Ghana cedis. And the budget was represented as B. So at least 10,000, meaning that 10,000 Ghana cedis is accepted, but not more than 20,000 Ghana cedis. So 20,000 Ghana cedis can or should be inclusive or included. So with this, the right answer for question 5 is option B. Now let's quickly work on question 6. Question 6. Now with question 6, we are told that 3 consecutive odd numbers sum up to 111. 3 consecutive odd numbers sum up to 111. So we have to find the product of the least and the largest of the numbers. So what do we mean by 3 consecutive odd numbers? So to get an understanding of this particular statement, we need to revise ourselves with the concept of odd numbers. What then is an odd number, or what are odd numbers? So with odd numbers, we are looking at numbers such that when these numbers are divided by 2, it will always leave a remainder. And I hope you can list the odd numbers. So the first odd number is 1. We have 3, we have 5, we have 7, we have 9, we have 11, 13, 15, 17 in that order. So what do you mean by 3 consecutive odd numbers? So with 3 consecutive odd numbers, we are looking at odd numbers that follow in a definite order. So can we list 3 consecutive odd numbers starting from 1? So 3 consecutive odd numbers starting from 1. We have 1, 3, and 5. Can we list 3 consecutive odd numbers starting from 7? 3 consecutive odd numbers starting from 7. We have 7, 9, and then 11. But then we are looking for the algebraic representation of odd numbers. So to get the algebraic representation of odd numbers, then we need to identify pattern for generating these numbers. So let's take a closer look. This is the first odd number. So from 1, the next odd number is 3. From 3 we have 5. From 5 we have 7. From 7 we have 9. 9 we have 11, in that order. So now from 1 to 3, you see that there is an addition of 2. From 3 to 5, there is an addition of 2. From 5 to 7, addition of 2. 7 to 9, addition of 2. 9 to 11, addition of 2. So if that is the case, then what if my first odd number is represented as k? If I represent my first odd number as k, then how do I write an expression for the second consecutive odd number? So the first odd number here was 1. To get the second odd number, they added 2. So if this time my first odd number is k, then my second odd number will be k plus 2. Second odd number is 3 here. To get a third odd number, plus 2. So if k plus 2 is my second odd number, then to get my third odd number, I have to add 2 to the second odd number. So my second odd number here is k plus 2. My second odd number here is k plus 2. So to get a third odd number, I have to add 2 to this. This will give me k plus 4. So my third odd number is k plus 4. So this is the algebraic representation of 3 consecutive odd numbers. So you can say that let the numbers be, so if the first odd number is k, then the second one will be k plus 2, then the third one will be k plus 4. Remember, their sum is 111. Their sum is 111, meaning that when we add these 3 consecutive odd numbers, that is k plus 2 plus k plus 4, it should give us a total of 111. So k plus k plus k, we have 3k. 2 plus 4, we have 6, and this must be equal to 111. You can group like terms. 3k is equal to 111, then we send positive 6 to the right, it becomes minus 6. So 3k is equal to, so 111 minus 6, we have 105. And since we are looking for k, you can divide both sides by 3. So we have k as So 105 divided by 3. We have k to be 35. So now can we list the 3 consecutive odd numbers? So if the first one is 35, and the second one will be 35 plus 2, which is 37. And then the third one here will be k plus 4, that is 35 plus 4, and that will give us 39. But remember, we have to find the product of the least and the largest of the numbers. So 35 here is the least. Least here means the smallest, and then the largest is 39. Remember, in algebra, product goes with multiplication. Product implies multiplication. So we have the least times the largest. The least times the largest. 35 times 39. 35. Let's verify and see. 35 times 39. So we have 1,365. So the right answer is option B. Question 7. The number of rooms at Hotel A is 30 more than twice the number of rooms at Hotel B. If the total number of rooms at Hotel A and Hotel B is 915, then what is the number of rooms in Hotel B? So we have two different hotels. We have Hotel A and Hotel B. So between Hotel A and Hotel B, which of them has the highest number of rooms? Remember, we are told that the number of rooms at Hotel A is 30 more than twice the number of rooms at Hotel B. So it is clear that Hotel A has more rooms than Hotel B. So if that's the case, then let's represent the hotel with the least number of rooms with a variable. So let's say the number of rooms in Hotel B is Y. If the number of rooms in Hotel B is Y, then how do we write an expression for the number of rooms in Hotel A, knowing that Hotel A has 30 more than twice the number of rooms at Hotel B? So let's focus our attention on this particular expression. 30 more than twice. 30 more than twice. What do you mean by 30 more than twice? So first of all, how do you write twice of the number of rooms in Hotel B? So twice of the number of rooms in Hotel B is Y, so twice of Y. In algebra, twice means 2 times. So 2 times Y. And then 2 times Y is 2Y. 2 times Y is 2Y. Now, how do we write 30 more than twice? 30 more than 2Y. So in algebra, more than implies addition. More than implies addition. So 30 more than twice. 30 more than 2Y. So we have 2Y plus 30. 30 more than 2Y. So okay, so let's pick it from this angle. Let's say you have this particular number here, 5. If I ask you to write a number which is 30 more than 5, what would the number be? 30 more than 5. So the number will be 35. 30 more than 5. So we just add 30 to 5. So 30 more than twice of y. So we just add 30 to 2y. So with this, the number of rooms in Hotel A will be 2y plus 30, which also represents 30 more than twice of the number of rooms in Hotel B. Now that we know the expressions for the total number of rooms in the two different hotels, we know that the total number of rooms in Hotel A and Hotel B is 950, meaning that the number of rooms in Hotel A, which is 2y plus 30, plus the number of rooms in Hotel B, which is y, must give us a total of 950. Now 2y plus y, we have 3y plus 30, and this must be equal to 950. So we have 3y is equal to, we group like terms. So we have 915 minus 30. So we have 3y is equal to 915 minus 30. I think that is 885. Remember, we are looking for y. We are looking for y, so we divide both sides by 3. We divide both sides by 3, so we have 3y is equal to 885. We divide here by 3, we divide here by 3. So 885 divided by 3. 885 divided by 3. 295. 295. Remember, we have to find the number of rooms in Hotel B, and that was represented as y. So we have the right answer as 295, which is also option A. Now, question 8. Question 8. We are to find the missing number in this particular pattern. So with the pattern, the first number is 3, 4, 5, 6, 7, 8. Then we have 3, 4, 5, 6, 7. We have 3, 4, 5, 6. We have a missing number, and the last number here is 3, 4. So when you take a closer look at the pattern, we see that the first number here has 1, 2, 3, 4, 5, 6. It has 6 digits. The second number here has 1, 2, 3, 4, 5, 5 digits. The third number, 1, 2, 3, 4, 4 digits. So it is obvious that the fourth or the missing number here should have 3 digits. So it is clear that the terms are decreasing in digits. But which of the digits is being eliminated? We see that always the last digit is eliminated. So the second term, 8, was eliminated. The third term, 7, was eliminated. So the missing term, 6, should be eliminated. So we have 3, 4, 5. 3, 4, 5. So the right answer to question 8 is option A. Question 9. You have to find the next two terms in the pattern. So this is the pattern. we have 21, 17, 13, 9, a missing term, and a missing term. So now, when you take a closer look at a pattern, you see that the numbers are reducing, or in other words, they are decreasing. So from 21 to 17, from 17 to 13, and then from 13 to 9, the numbers are reducing. So let's find the number that is causing the decrease. So from 21 to 17, from 21 to 17. So 21 minus 17, we have 4. So decrease of 4, so negative 4. Decrease means negative. So you see that when you subtract 4 from 21, that is 17. Okay, so let's also see the second difference. From 17 to 13, there is a reduction. 17 minus 13, we have 4. So it is a decrease, so minus 4. And then the next one, from 13 to 9. Let's see the difference. So there is still a decrease of 4. So it is clear that there is a decrease of 4 from one term to the other. So it means that from 9 to the next term, there must be a decrease of 4. Then from this term to this term too, there must be a decrease of 4. So minus 4 should be here, minus 4. So now we have to subtract 4 from 9, and that is 5. So the missing term here is 5. And then from 5 to the next term, we still have to subtract 4 from 5. And this will give us 1. So the next missing term here is 1. So from the alternatives, the right answer is option E. Question 10. In the diagram below, the expression in the top block is the sum of the expressions in the next two blocks directly beneath it. So what is the expression at the top block labeled K? So we have to find the expression that will be placed at the top block here. So when you take a closer look, we have 6 different blocks. Then these 6 blocks has been arranged in such a way that some blocks are sitting on top of other blocks. Now, how do we get the expression for a top block? Now, these 3 blocks here are at the base, so they are not a top block. These 2 blocks are part of the top blocks, and then block K is also a top block. So remember, we were told that to get the expression on a top block, to get an expression for a top block, what do? We need to sum up the 2 blocks, or we need to sum up the expressions in the 2 blocks that is directly under the top block. So let's verify this information and see. So let's say we want to find the expression for this top block. What do? You see that this top block here is sitting on 2 blocks. So the first block has the expression 2n, and the second block has the expression 6m. So to get the expression for this top block, what do? We need to add up these 2 expressions. And alphabetically, we know that m comes before n. So 2n plus 6m is also 6m plus 2n. And indeed, that is the expression at the top block. How do we get the expression for this top block? Again, this top block sits on 2 blocks. Now the first block has m minus 5n. And the second block has 2n. Our goal is to find the expression for this top block. So what do? We need to add up the expressions on these 2 blocks. So 5 minus 5n plus 2n. So we have m minus 5n plus 2n. So that will give us m minus 3n. So this block will have the expression m minus 3n. So finally, how do we get the expression for this top block? Again, block K is sitting on 2 blocks. Now the first block has the expression m minus 3n. The second block has the expression 6m plus 2n. We know that to get the expression for the top block, we need to add up the expressions on the 2 blocks directly under K, that is under block K. So I'm grouping like this. We have m plus 6m. We have minus 3n plus 2n. So what is m plus 6m? That is 7m. And what is minus 3n plus 2n? So we have minus 1n, which is the same as minus n. So finally, block K will have the expression 7m minus n. So the right answer is option B.